Alright, then, we're talking about our notes for today. So yesterday we talked about adding and subtracting, right? Yes? We talked about how we add and subtracted just the real parts together, just imaginary parts together. That is not the case for multiplying. With multiplying, we're going to do what we normally do. Right? If I have a number in front of my parentheses, what do I do with that number? Distribute it, right? We multiply. We distribute it throughout. Just because it's a real number, I am not just multiplying it by the other real number. I'm distributing it to both of my pieces. Right? So just like normal, I multiply it by both parts inside there. Or however many parts there are. 4 times 6 will give me 24. 4 times 9i will give me plus 36i. Once you've distributed it like you normally do, combine any like terms. Do I have any like terms?
No.
No. That's it. I'm done. Question 1's done. So when we multiply, guys, we're multiplying everything just like normal. Adding and subtracting is just real and real, imaginary, imaginary. This is just like normal. We multiply everything. Same thing here. We get 3i times 5 is 15i. 3i times 2i plus 6i squared. That is not what we're going to circle. That is not our answer.
Yeah.
Do you know what we're going to do?
Would you
turn it to -1?
Turn it to -1. Anytime we see I squared, guys, we change it to -1. Because real numbers are better than imaginary, right? We know I squared is always -1, and I'd rather have those real numbers. So anytime I see an I squared, I'm always going to change it to -1. So I get 6 times -1 instead of 6 times I squared, or 15i minus 6, or plus -6. Is that a good answer?
Yes.
The order's wrong.
No.
The order's wrong, right? We said yesterday, our formula, our standard form, A plus BI, real plus imaginary. It needs to be in that order. The real comes first, plus the imaginary. So in this case, I'm just going to switch the order. Becomes -6 plus 15i. And that would be a good answer. Those first two, do those make sense?
Yes.
Do you have any questions on those? Okay, then this third one. 5 plus 3i times 2 plus 7i. How am I going to multiply this? What's that? Foil, right? We're going to foil. First, outside, inside, last. You do not, absolutely do not, just multiply 5 times 2 and 3i times 7i and call it good. You need to do the whole process. 5 times 2 is 10. 5 times 7i is plus 35i. 3i times 2 is plus 6i. 3i times 7i plus 21i squared. Foil it out. Do the first numbers, the outside numbers, the inside numbers, and then the last numbers. What do you think I should do after that?
Combine your like.
Combine your like terms. So I have like terms 35i plus 6i. So 10 plus 41i plus 21. Do I put I squared in there?
Oh,
Times -1, right? Any chance we get to change out an I squared for -1, we're going to do that. So I get 10 plus 41i minus 21. Same thing, combine your like terms here. Right? I have a 10 and I have -21. So 10 minus 21 will give me -11 plus 41i. Remember that -11's got to come first. That real part must come first. Any questions on that? No? Okay, let's try 2 more. Same thing. -4 plus 9i times 3 minus 2i. Still got a foil. Right? -4 times 3 will give me -12. -4 times -2i will give me
plus 8.
plus 8i. 9i times 3 will give me plus 27i. And 9i times -2i will give me -18i squared. So remember that first step was to do what? Combine like terms and change I squared to -1. So negative 12 plus 35I minus 18 times -1. Hey guys, do you think as you get better at this and you realize that I squared is -1, do you think you have to write out this part?
Oh, I'm not sure.
Probably not. Like you can just do 18 times -1, that's fine with me. I'm going to write it out though. So it becomes negative 12 plus 35I plus 18, right? Negative 18 times -1 will be plus 18. And last step, combine your like terms again. Negative 12 plus 18 will give me 6 plus 35I. What questions do you have on that problem?
When you add 8 plus 27,
Yep.
why didn't the I become squared?
Because we're not multiplying it, right?
Oh, okay.
If it was 8 times 8I times 27I, then we multiply the i's as well.
Oh, okay.
Does that make sense?
Yeah.
Okay. Alright. Any other questions? Good question. Any other questions? Okay, we have one more like this. 5 plus 6I times 5 minus 6I. What do I do first?
5 times
5 times 5 is the beginning of what? Favorite 4-letter F word.
5.
Foil. Foil. 5 times 5 is 25. 5 times negative 6I is minus 30I. 6I times 5 is plus 30I. And 6I times negative 6I will be negative 36I squared. Okay, let's combine our like terms. When I combine my like terms, what happens?
They cancel off.
They cancel out, right? Negative 30I plus 30I, those will cancel to 0. I get 25 minus 36 times -1. Right? I squared always turns into -1. So 25 plus 36, which is 61. That's it. If you want to write 61 plus 0I, I'm fine with that as well. I don't know why you would want to do that, but you can. Alright, otherwise 61 is a good answer. Any questions on that? We good? Okay, let's keep rolling. We're almost done. The other thing we're going to talk about today is the conjugate, the complex conjugate. So, our complex conjugate for a complex number a plus bi would be a minus bi. What happens when we take the conjugate is all we're doing is switching the sign of the imaginary part of it. So for example, if I have 4 plus 2i, what's the imaginary part there?
2i.
2i. So to make the conjugate, I would switch the sign of 2i. So instead of 4 plus 2i, now it's 4 minus 2i. Because what's going to happen when you see, we'll multiply them together and something's going to happen. You'll see. Trust me. Okay? And we'll get more into it tomorrow even too. So if I have 4 minus 7i, what's my imaginary part? The negative 7i. So if I want the conjugate, it's me 4 plus 7i. Guys, I can guarantee you on the homework they're going to try and trick you and put the imaginary part first. Don't fall for it. Right? We're always changing the sign of the imaginary part. Doesn't matter where it is. Always the imaginary part. The real part stays the same. Okay. Now it wants me to multiply them. 4 minus 7i times 4 plus 7i.
Oh.
How do I multiply things like that?
Foil.
Foil. If I foil, 4 times 4 is 16. 4 times 7i is plus 28i. Negative 7i times 4 is minus 28i. Negative 7i times 7i is negative 49i squared. Hey, what do you notice happens again? What cancels out? The 28i's, right? 28i minus 28i. I get 16 minus 49 times -1, which is 16 plus 49. And that's 65. Hey guys, what do you notice about my answer on that one? And if you look back, the last problem we did too, that was a complex number times its conjugate. What do you notice about your answers? What are they missing? What don't they have?
Imaginary numbers.
They don't have imaginary numbers. Right? They don't have any i's. Anytime you multiply a complex number by its conjugate, you will not have any i's in your answer. And it will always be a positive real number. Alright? So, I kind of skipped ahead down to the bottom. We'll talk about it again when we get down there. But if we look at the second problem, the conjugate of negative 3 plus 2i is going to be what? Well, what's my imaginary part? Negative 3 minus 2i, right? 2i is my imaginary part, so I just switch the sign on that. It becomes negative 3 minus 2i. So if I go to multiply, negative 3 times negative 3 is 9. Negative 3 times negative 2i is plus 6i. 2i times negative 3 is minus 6i. And 2i times negative 2i is minus 4i squared. Once again, my i's in the middle cancel. Perfect, right? When I multiply by the conjugate, that should happen. 6i minus 6i cancel. I get 9. Oops. Minus 4 times negative 1. Hey,
Hi.
what's up?
I've got this thing if you want it. Can you look at it? One of those before I lose it.
Sweet, thank you. Alright. So that becomes 9 plus 4, which is 13. Right? Does that make sense? Okay, so once again, there were two things I said. What do you notice happens when you multiply by the conjugate? First thing is what?
No more imaginary numbers.
No more imaginary numbers. You should not have any imaginary numbers in your answer. So no i's in your answer. Let's write that one down and I'll ask about the second one. So no i's in your answer. What else do you notice when you multiply by the conjugate? What else did I say? It will always be what for an answer? What was that, Aiden?
Positive.
A positive real number, and a positive whole number even. Okay? Those are the two things we should notice. It will always be a positive whole number. Alright, any questions on what we talked about today? Multiplying, conjugates, anything? Cool. Alright.